If you haven't gotten to OYO 8.2, you get to do it all on your lonesome, and you just get to watch. But you do need to watch now. So Brendan, stop what you're doing and watch. And Jonathan, you're watching and you're discussing it with us. But I'll mainly ask Alex and Hannah these questions. All right, this one's a little different because it gives you the potential energy right up front. You don't have to calculate it. And it asks to find the heights of the hills. So we have some sort of car or cart. Here it has this mass and so forth. So we need to know where to start on one of these. So we know that PE equals what? Morgan, what's the equation for potential energy from yesterday?
Gee, I don't remember.
You can peek at that.
MGH.
MGH, all right. So we have MGH, but we already are told what the potential energy is. So it is 7.72 times 10 to the fifth. And I'll leave out joules, but you know that's what I mean. So do we know any of these parts? Alex, what do we know with numbers for these three parts?
I'm sorry, what was the question?
What do we know here, mg or h, in the problem?
In the problem. We know M and G.
All right, so what are they? What's m?
M is 365 kilograms.
And g?
And G is 9.8.
And h is what we're looking for.
Yes.
So you see why people said this one was so easy? Because we're ready to solve for h right away. So rather than taking the time to tap it in, what did h come up to be, Hannah?
2.2 times 10 squared.
2.2 times 10 squared. So let me write it as 220.
Yeah.
All right. All right. So do you see what we did on that one? And when you do it tonight, what we're going to do today is going to be a whole lot more involved. So just remember, this one's easy, so you don't have to fret about this one. All right, then we do the same thing. PE for this hill. PE is MGH. It's known. All right, this time, Alex, tell me MGH on this one.
MGH is the same.
It's the same. All right. 365, 9.8.
Oh, so that's the OYO.
All right, so Alex, could you peek and just tell us what the height is for the second hill?
I'm not sure if it's right, but I got 18.6 meters.
All right.
I rounded to 19.
Yeah.
When you did this one, what was the calculation at that point? Let me see what I got. I'll peek and see. All right, you got what, 19 or 18?
18.6.
18.6, so I'm going to grab 19.
Yeah.
All right. All right, I hear discussion, and I shouldn't. Is it taping now, Aaron?
Yes.
Okay. Hi, Annabella.
Oh, it's been taping for a little bit.
Sorry, I didn't know they'd start it. This is OYO 8.2, and we are going over, it was assigned last night, so I need to see yours when you come in, and hope you're okay. Oh, onward. Now, the problem with this one that I need you to zero in on is the question is, what are the two heights of the hills? And we were able to get it from knowing potential energy. However, this is the height of this hill. This is not the height of this hill because of the way the problem was worded. And who has their book open? Jonathan, has yours got 8.2 staring at you?
Yeah.
Could you read just read the problem, listen to what he says, and tell me if you can figure out why this is not the answer to this question. How high is height B? Read the question.
Okay. A roller coaster car, which is mass is 365 kilograms.
55?
365
Oh, okay. I thought I heard it wrong. Go ahead.
kilograms is at the top of the highest hill on the track. If the potential energy is 7.72 times 10 to the fifth power, joules relative to the ground, and 6.67 times 10 to the fourth power joules relative to the next hill.
Do you hear what he said? This is relative to the next hill. So it's sort of like the step problem. So when we got this height right here, that's all you have to read, Jonathan, thank you. This height, 19, is not the height of this hill. It is from the way the problem was worded. Did you notice this is your 19? So then how do we finish, Hannah? How do we get, if we got this hill was 220, and this hill was 19, I mean this spot was 19, how do we get the remaining answer?
Do you add them?
Add them?
Or subtract?
Would you just
We know
subtract
this, and we know this, and we need this.
Oh, then you subtract.
Right,
the-
okay,
Would you subtract 19 from the first?
yes. So what is 19 from 220? What is that?
201.
201. So we're gonna drop the 1, so we get 200. So in sig figs, we have to go 2.0 times 10 squared meters. All right. Okay, that would have been more meaningful had you done the problem. You're not allowed to write it down unless you're refining your answers that you've already done. So you'll be trying that on your own and showing me next time we meet. All right? Let's mess with these hills a little bit longer. This mod is one of those ones that you all get and you get it right every time or you're totally lost the rest of the mod. And all that hinges on today's work. So here we are at this point, we're teetering. Which way are you going to teeter? I really need your brain in this discussion. You too. All right, so, all right, we'll start out calmly. If you would, in your comp books, write down this law. The first law of thermodynamics is a lot easier than its title. First law of thermodynamics. If I start it, I bet you can finish it. It's one of those things you just pick up by being alive. Energy cannot be
Created or destroyed.
very good.
Wow, that was fast.
Energy cannot be created or destroyed. So what happens is, I'll put in parentheses, it just changes forms. And we'll talk about that a whole lot more later this mod, but just a little bit today. It just changes forms. So comp book's open and write that out. It just changes forms. All right. We're about to dive in now. I need a mass on the top of a cliff. So I won't erase this. I will in a minute. I need that boulder that is placed up on the top of the cliff and it is balanced.
Wait, is it supposed to be in the middle of the words?
No, I'm
Like
going to
for
erase
ours?
that. I'm just
Okay.
giving everyone a chance to write it down.
It's like a cool optical illusion.
Sorry, I have to ditch the optical illusion here. I need a mass teetering at the top, balanced right now. And at that point, from yesterday's discussion, is it have kinetic energy or potential energy at that point? How's that work? Do you remember, Abby? Is that all potential energy or kinetic?
I'm gonna have to go with kinetic.
It isn't, because kinetic is moving. Is this
Wasn't it about
moving?
to move?
Huh? It is.
Yeah.
And we'll come back to you in a minute. But right now, it's all potential. All PE. I'm going to call potential energy PE. All PE. Because it is no motion. So it's all MGH. All right, now I'm going to take this big cliff and push it over. So now you'll see that it is moving. And in fact, I'm going to go all the way, fast forward all the way down where it almost hits the ground. That looks like it did hit the ground, but imagine it the instant before it hits the ground here. So it's still moving. So this is instant before impact. So all right here, there's no potential energy because this height, mgh, is gone. It's all the way down at the ground, so it's all kinetic energy. And that was 1/2 mv squared. And that came from yesterday, formulas from yesterday. Does that make sense? So up here, all potential energy, no kinetic. Down here, all kinetic energy, no potential. What about, yeah, question?
Vanilla. What's that?
That's this thing.
That was the assignment.
you're just,
Assignment, we have to
Okay.
finish vanilla up to
I was
page
like,
10.
I was like, is it a
I mean, not page
coincidence?
10, number 10 on page 2. All right, so if this is all potential, no kinetic, this is all kinetic, no potential, guess what this is?
It's
Those
half,
mixture of
half
the-
potential.
All right, well, I don't know if it's half, but, all right, some potential, because it still has a height at this point, so we still could calculate an mgh. There's height involved, and there's some kinetic. So make a note of that and put those parameters there. All PE, some PE, all KE, some KE. Make sure you get that down. Does that make sense? Because it's going to be important that you understand that. It's really height that gives these things any potential at all. This, it has all potential. Here it has some height, some potential, but it has motion, so there's some kinetic. All right, you got that? Let me see your beautiful boulders. Beautiful boulders.
Look more like a bowling ball.
Circle.
I know.
Yeah, one,
Oh,
two.
there they are. All right.
It's like,
And then I need to erase, so all right, beautiful boulders. Where's your?
Alex.
Just remember that it's like half.
It's not really half. It's some. Some. All right. All right. So here's the big deal about teetering on the top, and that is something. Every system, we said, energy cannot be created, destroyed. Every system has a total amount of energy. So I'm going to call that TE. So here, TE equals the two added together, PE plus KE. But in this particular spot, what is KE?
0.
Right, there is no kinetic energy because there's no, remember you have to have a velocity to have kinetic energy. So this is 0. So at the beginning of the story, the total energy is all potential. So that's interesting. So if I needed to calculate the total energy and this was still, then I could go right here and get it. What about over here?
should I pause it real quick, Miss Pat?
Is it 10 minutes?
I don't know. Somebody, I haven't been.
Yeah, let's go ahead.